You ever get that feeling that your phone just gets you? Like it knows the exact movie you're in the mood for, or the perfect song you've never heard? Well, it's not magic. It's actually a secret language, one that's been running our digital world for about half a century now. And today, we're going to learn how to speak it. See, it all starts with a question. When an app recommends a new show, it's really just asking a giant digital library, hey, what other shows are a lot like the ones this person already binge watches? Every single recommendation, every notification, it all kicks off with a question just like that. But how do they actually ask it? You'd probably guess it's some kind of super advanced AI that was invented like last Tuesday. But the truth is actually way more surprising. The language that's used to talk to most of the world's data, it was cooked up way back in the 1970s at IBM. I mean, this is a technology that's outlasted disco, VHS tapes, and probably your first Hotmail account. And just to put that into perspective, take a look at this. SQL was born in 1974. That is almost 2 decades before Python and Java became the big names we know today. It's even older than the C programming language. So this isn't just old tech, it's literally foundational. So what is this incredibly tough, long-lasting language? Well, it's called SQL, which you can say as SQL, or as a lot of folks in the industry call it, SQL. And believe me, it is the unsung hero of our modern information age. At its heart, SQL, which stands for Structured Query Language, is, well, it's exactly what it sounds like. It's a structured way to ask or query a database for exactly the information you want. Think of it as the universal translator between you and mountains of data, letting you pull out just the right little pieces from a huge organized library. Now, the reason SQL has stuck around for so long is because it's just so beautifully simple. It's actually designed to be read almost like a plain English sentence. So, what do you say? Let's try asking our very first question. Okay, imagine you're in a library, but it's the size of a city, and you need to find one specific fact. You can't just wander around and yell, right? No, you've got to go to the librarian, and you have to be super precise. You have to tell them what you want, where to look for it, and any specific rules they need to follow. SQL works the exact same way. And this is the basic grammar, the magic formula, really. First, you select the information you want, like, say, the title of a book. Then you tell it from which table to look. That's like the science fiction section. And finally, you give it a where clause with your rules, like where the author is Isaac Asimov. Select from where. That's the core of the whole thing. All right, let's make this real. Here is a super simple table of users, kind of like what any social media app would have. We've got a user ID, a name, an age, and a popularity score. This is our book. This is the table we're going to start asking questions about. Okay, so here's our mission. It's a simple, clear question. We just want a list of the names of every user who is younger than 18. So using our new grammar, how would we ask that? We'd say, select the name column from the user table where age is less than 18. And boom, just like that, the database gives us exactly what we asked for. Nothing more, nothing less. It just zips through all the data, checks our rule, and hands back this clean, simple list. That right there is the fundamental power of SQL, asking incredibly precise questions and getting incredibly precise answers back. Okay, but what happens when the information you need isn't all sitting nicely in one place? Because let's be honest, real-world data is rarely that neat. And that is where SQL's next really cool trick comes into play. Yeah, see, data is usually split across lots of different tables, just to keep things organized. So here, we've got our user table with all the names, but then there's this totally separate member table that tells us which user belongs to which group. So how in the world do we find the names of people who are in a specific group? To pull this off, we use a command called a join. Now, join is the real powerhouse of SQL. It lets us basically stitch these two tables together for a moment, using the one thing they have in common, that user ID, to create a brand new temporary combined table that we can then ask our question to. It's pretty slick. So finding individual people is definitely useful, but the real magic of data is spotting the bigger trends and summaries. And SQL is absolutely fantastic at this. It can take thousands or even billions of individual lines of data and just crush them down into a single, insightful picture. Okay, so let's ask a much bigger question, something a real data analyst would ask. We don't want a list of users anymore. We want a summary. We want to know, What's the average popularity for all the 8-year-olds compared to all the 10-year-olds? To do this, we need a new tool in our toolbox, a command called group by. And just look at what we get back. With one simple query, SQL finds all the 8-year-olds, groups them together, and calculates their average popularity. Then it does the exact same thing for the 10-year-olds. It turns a messy list of individual numbers into a clear, actionable insight. I mean, this is the kind of stuff entire businesses are built on. All right, now let's talk about a kind of quirky but really important feature of SQL. See, unlike a lot of other systems, SQL does not mind seeing the same thing twice. In fact, a lot of the time, it actually prefers it. Let's dig into why that is. Think about it this way. If you're making a guest list for a party, you only want each person's name on there once, right? That's what we call a set, only unique items. But if you're counting votes in an election, every single vote has to be counted, even if they're for the same person. Duplicates are crucial. That's a bag. By default, SQL treats your data like a bag. So why is that the default setting? Well, as this quote here explains, keeping the duplicates is often just way more useful. If we ask for a list of all our user ages and we only get back 8 and 10, that doesn't really tell us very much. But if we get back 8, 8, 10, 10, 10, we suddenly get the user age distribution. We see the whole picture, and that's almost always what you actually want. So, we've seen how SQL works, from asking simple little questions to creating these big, complex summaries. But that still leaves us with a really big question. Why has this 50-year-old language not just survived, but actually thrived?
It really comes down to three things. First, its grammar is just simple and logical. It reads like English. Second, and this one is so important, it's declarative. That means you just declare what data you want, and you let the database figure out the fastest, most efficient how to go get it for you. And finally, it's a stable universal standard. If you learn SQL, you can talk to pretty much any database on the planet.
And that brings us to the future. You know, in this age of crazy complex AI and all these new data technologies, is there still a place for a language that's all about just asking clear, direct questions? Or is it that very simplicity that will guarantee it stays king for the next 50 years? Now that's something to think about.